Make sure to take notes. Those on their laptops, please shut them down and focus so that we can take notes. So last lesson we covered simple interest. Okay, and simple interest was the idea that every year you only increase by that same amount. And here's the example to remind you. Say you invested $1,000 into a bank account. The bank says if you keep the money there, they'll give you an extra 10% every year. You do that for 5 years. Okay, so here's the difference between simple and compound. I've got the numbers there for you, but I'm going to do the calculation so you can see. So you start off with $1,000. After the first year, if you leave it there for one entire year, the bank will then say, let's take 10% of that, and they'll add on top to what you currently have. Now, with some quick maths, 10% of $1,000, anyone know? 100. So that means you would then get $1,000, which is your original, plus the $100 interest they give you. Why is this called simple? It's because it's easier to calculate, because if you put it for 5 years, in the second year, even though right now your bank account is $1,100, you still add on $100. Okay, so it's still the 100, and that 100 came from the fact that you found 10% of what you invested. So that means after 5 years, you're just adding 100 5 times. You know what I mean? That's why the rule works. So in the third year, you get 1,200, but it's still plus 100. Fourth year is still plus 100 in interest, and the fifth year, it's still going to be plus 100. So what you can see is after 5 years, we went from 1,000 to 1,100, 1,200, 1,300, but each time was only additional plus 100. And you had 5 of them. Okay, so there's 5 of these. And so how do we calculate the interest? Instead of doing 100 plus 100 plus 100 plus 100 plus 100 5 times, there was a rule for you. What was the rule in our last session, just to recap, and how you would calculate that quickly? Because we know in total, the interest you gained was $500. That was the rule again. So interest was equal to what? Anyone remember? What was the formula from our last session? Interest is equal to... Stella? Good. P times R over 100 times N. R over 100 is the rate. Why is it over 100? Because percent means out of 100. So if they said 9%, it'll be 9 out of 100. If they said 10%, it's 10 out of 100. What's P? P is what you put in first. This is P. You start off with $1,000. So that's your principal is what they call it. That's why they call it P. N is the duration. Number of years. Okay, so if you think about it, 10% of 1,000 was 100, and 100 times 5, that's how you get $500. So that was the quick way to work it out by saying, I put in $1,000, 10%, which is 10 of 100, times 5, and you already told me 10% of 1,000 was 100, 100 times 5. That was a lot quicker following the formula than doing what I just did here, where we have to do 100 plus 100 plus 100 plus 100 plus 100 just to get $500 of interest. Okay, so that was the simple interest formula. That was 9.2. Today's lesson, we're now working on compound interest. Compound interest is different to simple interest on a small detail. Instead of the interest being exactly the same every year, so the first year, notice that the first year is still the same amount. So they both end up at 1,100. It's the same. And the reason for that is because you still do 1,000 plus 10% of whatever's there, which is 1,000. So that's true. But what's different in the second year, notice that extra $10, that's coming from the fact that it is now 1,100 plus, not 100 anymore, but this time it's 10% of whatever's left over in the bank. So whatever currently, because you've increased by an extra $100, it's 10% of 1,100. That's the key difference. See, this one over here was still 10% of 1,000 because that's what you put in. This one is always going to change depending on what's in your bank account. This is why the graph, when you sketch it, you can see the difference between the two. Simple interest is consistent. It's always $100 increase every year. This one will grow exponentially. So that means over long term, this is a lot better. That's why when they say, you might have heard financially, people say, if you want to start investing, the best thing to do is now. And the reason why is because you guys are young. What you guys have that I don't have or less have that you guys have is time. Your time, over time, even if I invested more money, even if I put in like another $5,000 on top of you, the fact that you have more time than I do, yours will grow much higher than mine in that by the same amount. So even if I started off with $5,000, you and I started $5,000 right now, by the time you get to 40, the amount of years that you put in, that will grow a lot faster than what mine would grow. Because in that same time, I would lose, well, if I actually had the same time as you, it would grow the same. But by the same age, by the time I get to 40, and by the time you get to 40, even if I put a lot more money compared to you, the time is what matters. This is where they say, you know, when you start investing, invest early. Start early. You could put it somewhere and it grows. And that's what a super does. The super is the idea of you keep contributing from your salary into something that later on when you're 65 you can access. The longer you invest in it, the more it grows. Yeah? So that's the difference between the two. It's mainly that second bit. It's the fact that whatever is there, it will take 10%. At the start, it's slow. But as the numbers get bigger, 10% of a bigger number becomes a lot bigger. So that's why over time, compound interest is better. So how do you use this to your own knowledge? Banks love compound interest. When they give you a loan to buy a house, they love this idea. They love to give you 30-year loan. They want you to stay on the loan because the longer you are on the loan, the more money of interest they'll get from you. That's why your aim is to pay the loan as soon as possible, not rely on the fact that you're going to pay it over 30 years. The aim is to actually do it less than 30 years. Okay? So that's the simple idea. What's the formula and how do you play around with it? This is what you do. Here's the formula. I've already wrote the formula down, but I want you to understand what each part is again. For the method students, then you'll understand this is exponential formula. For the general students, you may have seen this formula already and you just still need to know how to apply it on your calculator. So here we go. A is the future amount. So A, future value of loan.
It's not drawing on the screen.
Oh, what's going on? Okay. I think it's now working. All right, future loan. Formula for future loan. This is amount. This is P, initial value borrowed, invested, principal. So in our case, the principal was $1,000.
No.
Interest rate per time period. This is in years, which in our case, I gave you 10% per annum. And then number of compounding periods. Now, this is what students sometimes misunderstand. N is not years or duration. N is actually what we call compound. Now, to clarify that, you see when I say I put it in the bank for 1 year, right? That's duration. That's 1 year. But how many times does it compound, which means how many times do I do this? See this bit here? Each line is called a compound. Each time I apply the 10% is a compound. This is called a compound. So in this case, I did 1 compound, 2 compounds, 3, 4, 5 compounds. Okay? So the duration doesn't actually matter. It's more about how many compounds you do. So in a year, in 1 year, whoops, this is for you to understand here. In 1 year, even though it's the same duration, if I compound it 12 times versus if I compound it 365 times, even though they're both same thing, 12 months, so every month I compound it, or every day I compound it, the total amount is going to be totally different, even though it's still 1 year. So 1 year, we're more interested in how many times you are going to add that 10%. Like, or how many times are you going to add that rate?
So if you compounded it twice, you would be every 6 months. It compounded.
That's right, and it'll be less than the 12. The value at the end of the day will be less than the 12 times. The more you compound, the better. This is why the bank, if you ever read it, it says interest rate of like, say, 6% per annum. But if you ask how many times they actually charge you, they charge you per day. Every single day that you don't pay back your loan, they're compounding. And it seems small in the small run, in the short run. In the long run, it's huge. It's a huge thing because they're compounding they're doing 365 instead of once a year or twice a year or 12 times a month.
If they can compound every day, like you're saying, then how come if we put money into it, it can't compound every day? Or doesn't it?
It does.
Oh, it does.
It does. It's just that for us, that's why the savings account, sometimes it's like maybe 4% or 5%, but they say per annum. But the problem is per annum, if it compounds every day, you then got to divide the 4% into 365. Then that tells you actually how much of a percent every single day you're gaining. So 4%, if I do it on a calculator, let's take where's the calculator? If it's 4%, 4 out of 100, so 0.04, that's what you get by the end of a year, right? But if I divide that by 365, which is a very small decimal point, that's what you get per day. That's what you get every single day that they compound.
That's still a lot.
It seems so. It depends on how much savings you put in.
Every day, yeah.
Yes. So the larger you put in your savings, that's why they put a cap. So if you look at your savings account, they usually tell you what your cap is, and it's about like 200,000, because they already calculated that even if you put 200,000, they may give you a couple $100 back. You know what I mean? Rather than you putting $2 million in, and then you reaping the benefits of that compound. So that's why there's a cap on your savings account. They do that on purpose. Whereas on your debt, there's an unlimited debt. You can have a huge amount of debt. Yeah. And they will take that compound. So that's why working out a percentage per day, that's how you kind of calculate short-term, long-term, which one's worthwhile. But the idea, to use the formula, you have to know N is not just the number of years, it's the number of times you compound. And they will tell you. So they usually say, put for 5 years, but compounded daily, or compounded monthly, or compounded weekly. Then you have to change the duration to the number of compounds you get. Okay, I'll do an example so you get a feel of it.
So you never broke down what
Oh, sorry. Let me move this away. Whoops. All right. So in our case, in the example we had just now, so up here, the example, $1,000 is what you put in. $1,000. Your rate was 10% per annum, but your number of compounds. So it just so happens that in our scenario, I was compounding once every year. Okay, so it means that it's 5 times in 5 years. So even though it said 5 years, yes, that was true. But how many times was I compounding? I was compounding once a year. So that ends up being 5 times. Okay? The reason why I'm emphasizing this is because some of the questions will change it. They'll say 5 years, for example. But if they say compound 6 months, every 6 months, like what Liam was saying before. Look how cute that is. If they said 5 years, but you compound every 6 months, how many times a year would you compound? If every 6 months it compounds, how many times? 10 in total. Very good. So twice a year, in 5 years, it's 10 times. So then the number for N will equal to 10 in that example. Get me?
What happens if you're putting money in into and it's over a year compounding? Do you get the money for the money you started the account, or say you put like $500 to it?
As like extra?
Yeah, like you put like $100.
Yeah, so this is where this formula doesn't work. So the formula you guys learned in general, the finance solver, it takes into account if you put extra, what happens to that. This formula here doesn't take into account for that. This only takes into account that you simply you keep it as whatever you invested, and you don't put any extra and you don't take anything out. That's right. So that would work for like an ETF, for example, where you invest and you just leave it, set and forget, then you use this formula. The other one, that's a uni formula, which I did put in one of my notes for the next exercise. You guys no one should know it. That's why the general people use the finance solver on their CAS to solve if they had repayments. But in foundation, we will give you the repayments. We won't get you to calculate because you guys don't have the formula to figure that out. Yeah. But yeah, that's a very good question. If you change the amount per month or per day, that changes this formula completely. This formula literally assumes that nothing changes. As soon as you put it in, you didn't touch it for X amount of years. And that's the idea. So this is not the loan calculator. If you went to borrow money from NAB and they said mortgage loan calculator, they're using the formula from the uni side, which is your finance solver CAS calculator stuff. That's what it's doing. Yeah. All right, team, let's flip over the page. Let's do example 1 so you get a feel of it. Let's go. So $5,000 is invested for 4 years at 6.5% per annum interest. Compound, this is the key part. So compound it annually. If you see compounded annually, that's a nice thing. That's easier. That means that every year they compound once. So it's once a year. So that means in 4 years, if it compounds once a year, then how many times does it compound? 4 times. Okay, so because it's 4 years, compounded annually, that matches. So it's 4 times in that year. So n equals 4. Okay, n doesn't automatically equal 4 just because they say 4 years. It depends on this one. Depends on that line. Okay? All right, and the rest should be pretty straightforward. $5,000 was invested, so we know $5,000 your principal times 1 plus, now the rate. Why is it out of 100? Because it's 6.5%. So the rate is 6.5. So R is 6.5 over 100 to the power of n. In this case, n was the only one you had to be careful. So they say 4 years, but since you're compounding annually, every year is once. Therefore, 4 years is 4. So n does equal to 4 in this case. If they said compounded monthly, then in 1 year, it's 12 times. That means in 4 years, 12 times 4 is 48. Then n becomes 48. Okay, so you just got to be careful with that n component. All right, sweet. So we've got the formula there. Now it's literally typing your calculator. But because if you don't have a CAS, it's harder to type all that in one go. I would say with your scientific calculator, do the brackets first. Okay, so do this component first. So what does it say? It's 1 plus 65 divided by 100. Okay, so on the calculator, we'll still know that it's 65 divided by 100 first because of BODMAS. But because you got the power, you do need the brackets at the start and at the end. And there's a hat button. That means the power button. So on your calculator, you should put bracket 1 plus 65 divided 100. So the calculator will know this will come next. And they won't do 1 plus 65. If you're afraid, you can put brackets in between them. But I know most students don't. Okay, most students are too lazy to put in a bracket. So in your case, you're lucky. BODMAS still works. 65 division first before the addition. And then this means power. So on your calculator, you should have a button that looks like a hat to the power of 4. Okay? Once you get that answer, then you times it by 5,000. That's on a scientific calculator. Okay, so if you have a scientific calculator, at the end you got to times by 5,000. So that's the order I would write it. I would do bracket 1 plus 65. Or if you were careful with your brackets, you can technically do 5,000 times, as long as you have the bracket there, then you can type it all in one go. Okay?
So the top one that you drew is for the CAD and the bottom one is for scientific.
Yeah,
okay.
That's right. All right, I'm going to do it on my calculator so that you can see. I'm not sure if this one has powers though. Let's see if this calculator has powers. No, I don't have powers on this one. Maybe if I use a scientific. All right, cool. This is how you would do it. 5,000. So 5,000 times bracket. So you must have the bracket plus. So 1 plus 65 divided by 100. Close brackets. So you can see that they will do 65 divided by 100 before they do 1 plus. Okay? And then to the power of. So my button is this XY. So you might have the XY button as well. That means to the power of. So I'm going to do XY. So it gives you that hat. And then 4. Okay? And that tells me, do we all get the same answer?
Is it supposed to be 6.5 or 65?
Oh yeah, it is 6.5. Sorry. All right, 65. 6.5. No wonder. I was like, wow, that's a huge number. All right, that makes sense. 6.5. So my error, I'll do it again then. So let's do it again. We're going to do 5,000 times bracket 1 plus 6.5 divided by 100 to the power of 4. That makes a lot more sense now. So 5,000 after 4 years, I've now got 6,432. So I gained $1,432. Okay, which makes a lot more sense with only 6.5% interest. Okay, so answer here was 6,432.3317, which really is the same thing as saying $6,432.3. Sometimes the question will ask you how much interest you gained. In that case, you then have to subtract. So interest that you gained was 6,432.33. Take away what you invested, and that should tell you what's left over. Okay, so if I then said take away 5,000, tells me I've gained 1,432.33.
Wrote 6,433 interest.
Yeah, so for the interest, yeah?
Yeah, but you wrote 6,433.33, where you said it was 6.3, 6.4. I forget it. I think yeah, I'm sorry.
It's my handwriting, is it?
No, I just think you said it one way.
Oh, but I wrote it.
Yeah, you said it.
Yeah.
Here you wrote it 6,432 and then 6,432, but then it seems like you wrote it 6,433 in the calculator.
Oh, did I?
I think you did.
I think 6,432.
Oh, okay, sorry. Sorry.
But it looks so similar. You get it.
Yeah, my bad.
All right. So that's what you'll be doing in 9.3. It's seeing the difference between compound interest versus simple. I did give you another formula here. This is because if you're not strong with the algebra and you can't rearrange that compound interest formula, sometimes they ask you, how much do you have to invest to then get a certain amount? All right. So this is the formula if you want to know how much you need to invest. See, the other one is how much do you get by the end of that duration? This formula allows you to find out how much do you need to put in so that you know after 5 years how much if you wanted to get $5,000, how much do you need to put in? Yeah? So using that formula, how does this work? Here's an example. Determine the principal. So determine how much do you need to put into the bank so that it will grow $4,000 in 6 years. So say you need $4,000 in 6 years' time for whatever it is you want. If interest is compounded quarterly, so be careful there, compounded quarterly at 6.5% per annum. So here, what does compound quarterly mean?
Every 4 years?
No. Compound quarterly. So
Quarterly.
every 3 months, because you're dividing 12, so 1 year you divide it into 4, divide it into quarters. So write this in so that you know. This means every 3 months. Why? Because in 1 year there's 12 months. Quarters means divide by 4. So 12 divided by 4 gives you 3 months. And when they say quarterly, that means every 3 months. You will then compound it. So, let's read. Thanks, team. Thanks, boys. So, you know the amount is you want $4,000 by the end of 6 years. You know the percentage is 6.5% per annum. You know it's 6 years as well, but the problem is you're compounding quarterly. So that means every 3 months in a year, how many times does it compound per year? 4 times. But if you do it for 6 years, then how many compounds are there in total?
4 times 6.
Very good. So 4 times 6 gives you 24. So n is 24 quarters, but then the rate currently is in per year. This is per annum. So you have to make sure the rate matches it as well. So they don't charge you 6.5% every quarter. You have to then divide this. 6.5%, what would you divide it by? Divide by 4 because it's every quarter. Quarter is dividing by 4. So if you divide the year into quarters, then you got to divide the rate into quarters. So here, 6.5 divided by 4. 6.5 divided by 4 gives you 1.625. So this means it's 1.6, let me write that again, 1.625% per quarter. That's your rate. That's the rate per quarter. So every quarter, that's the percentage they're going to increase it by. They're going to do it 4 times a year. Now, over 6 years, they do it 24 times. Okay, so that's probably the hardest part. The only trickiest part of compound interest is to make sure R and N make sense. The rate has to make sense for every time they compound. So it's not the duration, it's the number of compounds. Okay? So if you put all that in correctly, we know it's $4,000 based on the rules. So A is $4,000. That's how much you want after 6 years. Your compound should be 24 times. And your rate is not 6.5%. It is now 1.625. The question is, how do you type that on your calculator?
What's the 24 though?
The 24 was 4 times 6. It's the number of quarters. So that's your N. All right, team. I've got the answer here for you, which is 2,716.73. Can you try on your scientific calculator, see if you can get this number? So you know it's 4,000 divide. On your green calculators, you can actually type a fraction. You can type up the fraction. But if you don't have a green calculator, then this is how you're going to do it. 4,000 divide, and you have to use the brackets. The brackets actually matter in this case, so you must use the brackets, otherwise it won't work. 1 plus 1.625 over 100, and then to the power of 24. Okay, so on your scientific calculator, if you type the way I've just shown you, should get the same answer. Should get the same answer. Okay, and that's it for today's lesson. It's a big one. It's applying compound interest. So learn this one for the year 12s. Year 11s, you got at least the next year to really master it for the exam. You guys mainly do simple interest in your exercise. So there's less compound.
So easy. Literally, it's just seeing what are the percentages of the numbers that it's adding on.
And that usually works for term deposits. So there's things called services in banks called term deposits. They do simple interest because usually it's short term. Long term, anything that's long term, they use compound. Yeah. All right, team. I'm going to stop the video there.